All right, in this question, we're asked to solve the initial value problem and find the value of y when x is equal to 3. We're given the differential equation, dy by dx minus 1 over xy is equal to x, with initial condition y is equal to 4 when x is equal to 1. Let's break this down into steps. Step 1, step 0, which I won't write down, is to determine what type of differential equation this is. And we only have two types. There's a separable type and there's a linear type. And this one is linear. We're going to put it into standard form. Which for a linear differential equation is y prime plus y times p of x is equal to q of x. So our goal is to make the expression look like this, and it's very close to that already. We have dy by dx, which is the same thing as y prime. And the next piece, minus 1 over x times y, I gotta fix that up a little bit. I'm gonna write that as plus y multiplied by negative 1 over x is equal to x. Okay, next, once we put it into standard form, step 2 is to construct the integrating factor I of x from e to the integral of p of x. Okay, so what is p of x? P of x is this thing here, including the minus sign. P of x is negative 1 over x. It's really important that we rewrite the differential equation in this standard form before we try to do anything. If we miss that minus sign, everything kind of goes sideways, it goes haywire. All right, I'm going to integrate p of x first, integral p of x dx, so that's the integral of negative 1 over x, which is negative ln absolute value of x. And because we're working in differential equations, I'm going to drop the absolute value symbol. I mean, you'll not run into problems with the types of questions we work on by dropping the absolute value. And for reasons that are described in the notes and the videos, I'm also going to drop the plus c that comes out of a definite integral. Okay, I'm only dropping it for the integrating factor calculation, not later on. Now, I of x, that's e to the integral of p of x. So that's e to the negative ln of x. And we can't cancel it yet. We have to use an exponent law. I'm going to bring up that negative 1 in front of the ln. Bring that up as a power inside the argument of the function, argument of the expression. And now we can use the cancellation law. And I get x to the power of negative 1, which is 1 over x. Okay, so that's my integrating factor. That's my I of x. Step 3, use the big formula, which for a linear first order differential equation, it says that the solution to this differential equation in terms of our integrating factor is 1 over I of x times the integral of I of x times q of x. Okay, so I'm just going to substitute everything in. I have 1 over x times the integral of 1 over x times q of x. Now what's q of x? Q of x, looking at our standard form, is just x. So 1 over x times x dx. Now in that term in front of the integral, that's 1 over x. So 1 divided by a half is going to be 2. 1 divided by 1 over 7 is going to be 7. 1 divided by 1 over x is just going to be x. So x times the integral of. And now we have 1 over x times x. Well, it's just 1. Okay, so that's not a nice, or sorry, that is not a bad function to integrate. What is the antiderivative of 1? And the answer is x plus c. And then I'm going to use the initial condition. Use y equals 4 when x equals 1 to find c. So remember that our formula said that y was equal to this thing. So that's what we found. We found the function. Now I'm going to use the condition to replace y with 4, replace x with 1. So 4 is equal to 1 plus c. Subtract 1 from both sides. C is equal to 3. I'm running out of space, so I'm going to continue over here. And then we found y is equal to x times x plus 3. That's our solution. Now, step 5, find y evaluated at 3. That's what the question says to do up over here. Okay, so this is going to be 3 times 3 plus 3. So 3 times 6, which is 18. And that would be the answer that we would select.